If we start by graphing these lines, x plus y is equal to 2. That's equivalent to y is equal to negative x plus 2. So that means the y-intercept is here. And the slope is negative 1, so I'm just going to label a few points. And then I'll sketch in my graph around these points. So there's my first equation. The second equation, let's see, we have, if I add 1/2 x to both sides, this is y is equal to 1/2 x minus 1. So this has a y-intercept at negative 1, and the slope is a half, so I go over 1 and up 2. Oh, I can actually see that they're going to meet up right at that one point I drew. So if I would like to draw the line going between these points, this is what I have. So it looks that the point where they intersect is at 2, 0. All I have to do now is just plug this in and see if they make both equations true. So let's start with x plus y is equal to 2. If I put 0 in place of y and 2 in place of x, is this a true statement? And the answer is yes. If I now check negative 1/2 x plus y is equal to negative 1, if I put, again, 2 in place of x and 0 in place of y, is this a true statement? And again, we have that the answer is yes. So essentially, we graphed both lines. We saw they met at one point, and I verified that that point makes both equations true at the same time. In fact, this is the only point where that happens. All right, we're going to graph both of these lines. I think for x minus 3y is equal to negative 3, I'm going to use an x and y intercept approach. So that is, if y is equal to 0, I get in my equation that x is equal to negative 3. Whereas if x is equal to 0 in my equation, I get negative 3y is equal to negative 3, and dividing both sides by negative 3 gives me y is equal to 1. So I have negative 3, 0 as my x-intercept, and I have 0, 1 as my y-intercept. So I can plot negative 3, 0, and 0, 1. My line goes to those 2 points. Okay, so I have my line. For my other equation, I could use a y and x-intercept approach, but instead I think I'm going to subtract x from both sides and use the slope and y-intercept. So here 5 is the y-intercept, the slope is negative 1, and I can see that these meet up at this spot here. So I'm going to now sketch this line. It appears that the intersection point is at 3, 2. It's this point that should make both equations true at the same time. So let's actually check that out. So an x minus 3y is equal to negative 3. I'm going to put 3 in place of x and 2 in place of y. This is 3 minus 6. Is that equal to negative 3? And the answer is yes. Those two are in fact equal. So 3, 2 makes that equation true. It should be that x plus y equals 5 is going to be satisfied by 3, 2 as well. So 3 goes in place of x, 2 goes in place of y. 5 is in fact equal to 5. And yeah, the point 3, 2 worked in both equations. It's the only point where that happens, and that's our solution. All right, so the goal is to now not use a graph in solving the remainder of our system of linear equations. The next one is y is equal to negative 3x minus 1, and 6x minus 2y is equal to 6. We're going to use substitution in questions 3 through 8. So essentially, I'm going to take this y and plug it here, but I'm going to use negative 3x minus 1 instead. In all these questions, we're taking two equations and reducing it down to 1. So that is, in my second equation, wherever I see a y, I'm going to put minus 3x minus 1. The rest is now solving this equation for x. I'll distribute in the negative 2, which gives us 6x plus 2. I have 12x plus 2 is equal to 6. I can subtract 2 from both sides. That gives me 12x is equal to 4. And after dividing both sides by 12, I get my answer, that x is equal to 1/3. Okay, I now need to know what y is equal to, but I can simply go back to the very first equation and put 1/3 in place of x. And when I solve for y, I get, let's see, okay, so 3 times 1/3 is just -1 in this case. So this is just -1 minus 1. Y is equal to -2. The answer is 1/3 for x and -2 for y. For this one, I'm going to solve the first equation for y by adding x to both sides. And then I'm going to take this value of y and plug it in over here. I get 2x plus x plus 1 is equal to 10. So that really is 3x plus 1 is equal to 10. I'll subtract 1 from both sides. I get 3x is equal to 9. Therefore, after dividing both sides by 3, I get my answer for x of 3. I still don't know what y is, but I can go back to y is equal to x plus 1, put 3 in place of x, and I have my answer of 4. The answer to this problem is 3 for x and 4 for y. For question 5, I think, again, if I'm using substitution, I'm going to take this y and plug it in over here. So taking the second equation and it's going into the first. So I get x minus 3 times 2x plus 7 is equal to -1. So I'll distribute the -3. I get x minus 6x minus 21 is equal to -1. So if I combine like terms, I get minus 5x minus 21 is equal to -1. I'll add 21 to both sides. I get -5x is equal to positive 20. And after dividing both sides by -5, I get x is equal to -4. I still need to know what y is equal to, so I'll go back to y is equal to 2x plus 7 and put -4 in place of x. So I get 2 times -4, that's -8, plus 7 is -1. This is my answer, -4 for x, -1 for y. For this one, we're now solved for x. So I'm going to take what x is equal to and just plug it in right here. So in my first equation, I get 7 times 2y minus 1 minus y is equal to 4. I will distribute the 7. So we get 14y minus 7 minus y is equal to 4. So combining like terms, I get 13y minus 7 is equal to 4. And after adding 7 to both sides of my equation, I get 13y is equal to 11. Dividing both sides by 13, I at least have what y is equal to. Y is equal to 11/13. So what is x? I will now go back to my original equation, x equals 2y minus 1, and put 11/13 in place of y. So this isn't going to be like a nice number or anything like that, but we have x is equal to, I multiply the numerators and denominators, I get 22/13, and I'm subtracting 1, but I'll write that as 13/13, because 22 minus 13 is going to be 9. And this is my answer, 9/13 for x and 11/13 for y. All right, so in this equation, I think my approach will be take this x, plug it in here. So in the second equation, I get 3 times 4y minus 2 minus y is equal to 5. If I distribute the 3, I get 12y minus 6 minus y is equal to 5. I'll combine like terms, and 12y minus y is equal to 11y. If I then add 6 to both sides, I get 11y is equal to 11. Okay, this is good this time, because if I divide both sides by 11, I get that y is equal to 1. Okay, now to figure out what x is equal to, I'll go back to the equation 4y minus 2, and in place of y, I'll plug in 1. So I get 4 minus 2 and x is equal to 2. This is my solution, 2 for x and 1 for y. All right, so both of these are y is equal, so we can just simply set these two things equal to each other. So that is x plus 1 is equal to negative 3x plus 9. I mean, you're kind of, I guess, substituting one equation to the other, but it's pretty irrelevant. For this one, I'm going to add 3x to both sides, and at the same time, why not just subtract 1? And when I do this, I get 4x is equal to 8. This one actually simplifies nicely. I divide both sides by 4, and I get that x is equal to 2. I'm going to choose the simpler of the two equations to plug my value 2 into. So I'm going to choose y equals x plus 1. That means 2 goes in place of x, and therefore y is equal to 3. This is my solution, 2 for x and 3 for y. In questions 9 through 14, we're going to use the addition method to solve for x and y. And for this equation, there's not much setup work that you have to do. We can simply just add the two equations together, and the reason for that is I have a negative y and a positive y, meaning they cancel. This is our ultimate goal, cancel either just the x's or just the y's. In doing so, we get 7x is equal to 7, and immediately we can just divide both sides by 7 to solve for x. X is equal to 1. The only thing that we don't know is y, and we can use either equation that we started with to figure it out. I'm going to say 5x minus y is equal to 4. I'm going to put 1 in place of x and solve this equation for y. That's 5 minus y is equal to 4. I suppose I don't know, subtract 4 from both sides, and why not at the same time add y? In doing this, I get 1 is equal to y. This is my solution. It's 1 for x and 1 for y. All right, to solve this equation, I think I'm going to take the first equation and multiply it by negative 1. I'm just going to leave the second equation alone. I'm not going to do a thing to it. And in my first equation, I get 3x minus 2y is equal to negative 1, whereas my second equation stays the same. And this is a good technique because now, if I add the two equations together, you get 8x, the y's cancel, and you get 18. If I divide both sides by 8, I get that x is equal to 18/8, or 9/4. You could use a decimal if you'd like, but I think I'll leave it just like this. All right, I think to solve this thing for y, maybe the very first equation is the easiest one to use. So, okay, I get negative 3x plus 2y is equal to 1. I'll put 9/4 in place of x and solve for y. So that, since I have 3 over 1, that's really negative 27/4 plus 2y is equal to 1. And maybe I'll note that 1 is the same thing as 4/4. It's not extremely important that you do this, but when you add 27/4 to both sides, it'll just make adding the 4/4 easier. We end up with 2y is equal to, okay, 27/4 plus 4/4 is 31/4. If I divide both sides by 2, this 2 goes into this denominator, making this 4 an 8. So y is equal to 31/8, and that can't be reduced. My answer's got some fractions, but we have 9/4 for x and 31/8 for y. For these two equations, using the addition method, I'm going to multiply the first equation by 2. And I'm going to leave the second equation alone. I get 4x plus 2y is equal to 14, whereas my second equation is x minus 2y is equal to 6. I didn't change it, but this is going to work out nicely for us because if we add these together, the y's cancel. I get 5x is equal to 20. And if I divide both sides by 5, I get that x is equal to 4. Again, the only thing I don't know is y. I think I'm going to use the very first equation to figure out what that is. So I'm going to take 2x plus y equals 7 and put 4 in place of x. And I get 8 plus y is equal to 7. Clearly, if I subtract 8 from both sides, I get that y is equal to -1. And this is my solution. 4 for x, -1 for y. For this question here, I think I'm going to cancel the x's. So I'm going to multiply the first equation by -3, and I'm going to multiply the second equation by 7. Not the only way to do this, but it's the first thing that jumped out at me. Multiplying the first equation by 3 gives me -21x minus 24y is equal to -12. It's a -12. And then the second equation, if I multiply by 7, is 21x minus 35y. And then, of course, obviously 27 times 7 is 189. I'm now adding these two equations together. Don't forget that that was really supposed to be a negative right there. All right, in doing so, the x's do cancel. And when we add the coefficients of the y's, just want to double check that. -59 y is equal to 177. I'm dividing both sides by -59. So that's my answer for y. Let me write that out there. Okay, dividing by -59, I get that y is equal to -3. So I do not know x. I suppose I'll use the first equation to figure out what that is equal to. So in my first equation, I'm solving for x. So 7x plus 8y is equal to 4. 7x I leave alone. I put -3 in place of y. So 7x minus 24 is equal to 4. So 7x is equal to 28. I'll just put in there that what I'm doing is adding 24 to both sides of my equation. And after I divide both sides by 7, I get my answer of x equals 4. And this is my solution, 4 for x and -3 for y. For this system, I think I'll try to cancel the y's. I'm going to multiply the second equation by -1. So I'm leaving this alone. This one I'm multiplying by -1. So I get 5x plus y equals 10. I didn't change anything. The second one is going to be 4x minus y is equal to -28. Because now, if I were to add these together, I get 9x, the y's cancel, and I get -18. And if I divide both sides by 9, I get that x is equal to -2. Perfect. Okay, I want to figure out what y is equal to. I think I'm going to choose the second equation for this. That is -4x plus y is equal to 28. I'm putting -2 in place of x, and I'm solving for y. So that is 8 plus y equals 28. I'm subtracting 8 from both sides, and I get my answer that y is equal to 20. Overall, the solution is -2 for x and 20 for y. All right, so for 14, I think the best approach here would be to maybe multiply the second equation by -7. So I'm leaving this first one alone. It's just -9x minus 7y is equal to -63. But my second equation, if I multiply it through by -7, list that out there, I get -49x. I get plus 7y, and then 49 times 7, negative 7, is negative 343. Okay, now, if I add these together, okay, I think this should work out, but anyways, we have negative 49 minus 9, and I get negative, let's see, negative 58x. And then if we look at 343 plus 63, that's negative 406. Now if I divide that by 58, that actually works out to be an integer. That's nice. Okay, so dividing both sides by negative 58, I get that x is equal to 7. Nice. All right, so I need to know what y is equal to. I'm going to choose the second equation. So that is in 7x minus y is equal to 49. I'm going to put 7 in place of x and solve this thing for y. So I get that 49 minus y is equal to 49. If I subtract 49 from both sides, I get that negative y is equal to 0. And if I divide both sides by negative 1, I mean, you could do this if you want, clearly y equals 0 has to be the solution. My solution is 7 for x and 0 for y. Okay, so for this system, I think something strange is going to happen, like it's going to be different than what we've seen before, but I want to try to cancel, I guess, the x's. And I'm going to do that by multiplying the top equation by 2 and leaving the second equation alone. The top equation is going to be 2x plus 2y is equal to 8, and the second equation is negative 2x minus 2y is equal to negative 8. If I now were to add these two together, I get that everything cancels. I get 0 is equal to 0. What does this mean? These two equations are actually the same equation. I mean, if you had multiplied by negative 2, it would have been identical to the thing down here. That means if you were to graph both of these, they're in fact the same line. This means that every single point is a solution. If you take your system and you get like 0 equals 0 or 5 equals 5, all this means is that every point is a solution to the equation. There's infinitely many solutions. So I'll put infinitely many solutions. It just means that every single pair of points that you choose on this line also make this line true as well. But what about this system? Again, I think something different is going to happen here, but I think I'm going to try to cancel the, I'll try to cancel the x's again, which means I'd have to multiply the top equation by negative 2, leave the second one alone. I get negative 4x, then I get plus 2y is equal to negative 2. And my second equation is 4x minus 2y is equal to 6. And if I were to add these together, I get 0 on the left, but on the right, I get 4. And this is false. Maybe I can even put for emphasis up here that, well, we got something true in the previous question, but this second one is definitely a false statement. And this means there's no solution. So if you graph these two lines, they are parallel. They're not the same line. They're actually two different lines, but they never actually meet, which means there's no point that can make both true at the same time. This would happen in any case where you get two numbers that are not equal to each other. I wanted to just try one example where we do a system of 3 equations with 3 unknowns. The goal is to reduce it down to 2 equations. Like if you think of all the previous ones, it was like take 2 equations, reduce it to 1 equation. Here, our first step is going to be take 3 equations and reduce it to 2. The way I'm going to do this is by first adding the first 2 equations. And I notice that I cancel the z if I do that. If I add the first 2 equations together, I get 3x minus 2y is equal to negative 4. Nice. Now, if we add the second two equations together, this time we get 4x plus y. The z's cancel, and I get negative 6 minus 3, which is negative 9. What we've done is we've reduced this down to something we already know how to solve. We have two equations with two unknowns. So what I'm going to do now is cancel the y's. I'm noticing that if I had a 2 here, these would cancel perfectly. So I'm going to take this equation and I'm going to multiply it by 2. Let's rewrite this whole thing over again. I have 3x minus 2y is equal to negative 4. But my next step is going to be to multiply this equation by 2. And when I do that, I get 8x plus 2y is equal to negative 18. And when I add these two equations together, I get 11x is equal to negative 22. So I started with 3 equations. I reduced it down to 2 equations. I then took those 2 equations and reduced it down to 1 equation. It's really easy to solve this thing for x. I'm just going to divide both sides by 11. And I get that x is equal to negative 2. This time, I have to figure out y, but actually I also have to figure out z. So let's get y first. I'm going to go to this equation, put negative 2 in place of x, and solve for y. Okay, so to do that, I have 4 times negative 2 plus y is equal to negative 9. That's negative 8 plus y is equal to negative 9. And adding 8 to both sides gives me that y is equal to negative 1. So over here I had x was equal to negative 2. Over here I get that y is equal to negative 1. The only thing I don't know is z. And what I'm going to do is use the very first equation to figure out z. That means I'm going to put negative 2 in place of x. I'm going to put negative 1 in place of y. The only thing I don't know is z. But when I solve for it, I get negative 2 plus 1 plus z is equal to 2. That's negative 1 plus z is 2. And when I add 1 to both sides, I get that z is equal to 3. This is my solution. It's negative 2 for x, negative 1 for y, and 3 for z. To solve this system, what I'm going to do is figure out where the two are equal. I'm then going to graph both lines, and then I'm going to choose the correct quadrant to graph. So let's start to figure out where these are equal. So 2x minus 1, where is that equal to x plus 2? I'm going to subtract x from both sides and also add 1 to both sides. And I get that x is equal to 3. This is where the two graphs meet. So let's start by graphing 2x minus 1. So I'll do that in blue. Graph 2x minus 1. And there's no equal sign, so I'm going to put a dotted line. So here I have negative 1, and the slope is 2. So I'll use these points. Slope is 2. My equation goes between those points. There's my line. My other equation is going to be y equals x plus 2. This one has a slope of 1, a y-intercept of 2. So here's a y-intercept of 2. We have a slope of 1. And these actually do meet up at x is equal to 3, so that's good. And my equation goes between these. Okay, so now that I have these two equations graphed, the next thing to do is to decide which of the 4 quadrants am I going to shade in. One kind of trick you can do here is, okay, if we're greater than this line, so here's 2x minus 1, if you're greater than that line, it means you're above it. And if you're less than this line, it means that you're below it. it would seem that the overlap is going to be this region here. And I'm going to check this by using 0, 0. Does it make both of these inequalities true? So let's see. I'm going to go to y is greater than 2x minus 1. I'm going to put 0 in place of x and y. And I get 0 is greater than negative 1. That's true. I'm now going to go to y is less than x plus 2 and put 0 in place of both x and y and ask, is this thing a true statement? And it is. Because of this, the solution is going to be everything between those 2 points, those 2 lines. You could try to choose a point from the other 3 regions, but they won't work for both inequalities, and this is my answer. Okay, to solve this system, I'm going to, again, graph both of these lines. The first line, since it has an equal sign, means it's going to be a solid line. This line, since there's no equal sign, means it's going to be a dashed line. So let's see here. For x plus y is equal to 2, I'm going to use an x and a y intercept. I'm going to do this in blue. So x plus y is 2. It goes through the point 0, 2, and 2, 0. So let's sketch that line. Okay, to get my second equation, I think I'm going to solve this one for y. This is y is equal to 2x minus 4, meaning negative 4 is the y-intercept and the slope is 2. I can see that these 2 lines are going to meet up at that point. This one, again, is supposed to be a dashed line, so I'll put it like this. Okay, I now have to choose the correct quadrant. Okay, so what is that going to be? Let's see. I think I'm going to try to choose, maybe I'll start here, the point 5, negative 5. I'm going to use that as a test point. All right, so we're going to check 5, negative 5. Does it make both of the original inequalities true? I'll start with x plus y is less than or equal to 2. I put 5 in place of x and negative 5 in place of y. Is this a true statement? And the answer is yes. Great. I now need to check it in negative 2x plus y is less than negative 4. So I'm going to put 5 in place of x and negative 5 in place of y. Is this a true statement? So this is going to be negative 10 minus 5. Is that less than negative 4? And certainly, negative 15 is less than negative 4, so that's true. This means that this is the solution. And again, you could try a point from the other 3 regions, but it won't make both inequalities true. Okay, so there's no equal sign on either of these, so it's just going to be a dotted line for both. The top one, I'd like to graph y is equal to 5, and that's just a horizontal line at 5. So kind of like it's here. And then x minus y is equal to 2. If I want to graph this, I think I'm going to add y to both sides and subtract 2 from both sides. This is the equation I'd like to graph. Y is equal to x minus 2. So there is my y-intercept. I know the slope is equal to 1. So here this thing is going between these points. We intersect right there. I think it's good enough to just draw this equation. Okay, again, I have 4 regions. 1, 2, 3, 4. Which one do I want to choose? Let's see. So how about, I don't know, I'm not really sure which will work, but maybe I'll start up here. And I'm going to choose the point 0, 10. In my first inequality, doesn't make it true. I put 10 in place of y. The 0 goes nowhere, and okay, this one's obviously true. For x minus y is less than 2, again, I'm putting 0 in place of x and 10 in place of y. Is this thing a true statement? Yeah, that's actually also true. I was thinking that wasn't going to work, and I was going to have to choose another point like maybe 10, 6, something over here, but I got it on my first try. This means that the solution is all of this stuff up here. All right, so for this one, I'm going to use a solid line for the very first equation. So I want to graph y equals negative 1/2 x. and that has a y-intercept of 0 and a slope of -1/2. So just getting a few points up here like this. My graph goes between these points and it's a solid line. So there's my equation. The other one I'd like to graph is y minus 5 is equal to 2x. There's no equal sign, so this one's just going to be a dotted line. I'm going to add 5 to both sides and graph 2x plus 5. So I have this point here, and the slope is 2. So just to get a few points up here. Okay, I see that we have our intersection point, and I just want to draw a dotted line going between these points. Okay. All right, so let's see. I want to be less than this line, but I want to be greater than this line. It kind of indicates that I want to choose something over here. I'm going to choose -5, 0. Does that work in the two original inequalities? So for y less than or equal to -1/2 x, I put 0 in place of y. I put -5 in place of x. I get 0 is less than or equal to a positive 5/2. I mean, that's definitely true. Well, 2.5 is 5/2, so that works. For the second one, y minus 5 is greater than 2x. So in place of y, I put 0 in place of x. Again, I'm putting -5. And I get -5 is greater than -10, and that's also true. So this is it. These are all the points that make the inequality true, both of them at the same time. Okay, I'm going to graph 3x plus 2y equals 6. And of course, I'm going to use a dotted line, as there's no equal sign in the original inequality. So I think it makes sense to use an x and a y-intercept for this one. The x-intercept, let's see, that's going to be 2, 0. And the y-intercept is 0, 3. And my line goes between those 2 points. All right, for my other equation, I have x minus 4y is equal to 2. Let's see. Yeah, I'm not really seeing a great way to graph this one. Okay, so I guess to get a couple of points, maybe I'll start by saying, well, if y equals 0, my equation becomes x is equal to 2. Okay, actually, that gives us a point really quickly, right? 2, 0. Oh, that's actually this point right here. If I want a second point on my equation, maybe I'll choose y is equal to 1. Just making this up. Here, if I solve for x, I get x minus 4 times 1 is equal to 2. So that's x minus 4 is 2, so x is equal to 6. Over here, x equals 6, I get y is equal to 1, and my equation goes between these 2 points. And I'm noticing that I drew a line that was supposed to be a dashed line. So let's kind of fix that here. Okay, now I have 4 regions to check. Let's see. For this line here, I think I'd like to be above this line. And I suppose I want to be below this line. I'm thinking we're over here. So I'm going to try 5, 0 as my test point. In my first inequality, which is 3x plus 2y is greater than 6, 5 goes in place of x, 0 goes in place of y. Is this thing a true statement? And the answer is yes, 15 is greater than 6. In the second inequality, if I put 5 in place of x and 0 in place of y, I get 5 is greater than 2, and that's also true. So what that means is these are all of the points that work. All right, so for this last one here, I'm going to graph y is equal to -2x plus 1 and use the dotted line. So here is 1, and the slope is -2. So just want to carefully get some points on here. And this is my equation. All right, now I'd like to graph, let's see, 8 is equal to 4x plus 2y. I'm going to divide both sides of this by 2. And if I do that, okay, I get 4 is equal to 2x plus y. And if I subtract 2x from both sides, I get -2x plus 4 is equal to y. So in this case, I have that the y-intercept is 4 and the slope, it's again -2. So, all right, these are my points on my line. I'll sketch this one. These two lines are parallel and they never intersect. They both have a slope of -2 but different y-intercepts. So this is weird. There's actually only, well, I think there's only 3 places to check. I mean, it's either going to be here, here in the middle, or all of this stuff over here. Yeah, let's see. I'm going to try this point here. This is the point 0, 2. All right, in my first inequality, I put 2 in place of y and 0 in place of x, and I get 2 is greater than 1. That's true. And 8 is less than 4x plus 2y. I put 0 in place of x, and I put 2 in place of y, and that is false. So no, that does not work. So that means, okay, I can't be between these two equations. This point did work for this graph, but it just didn't work for this one. Okay, so my next choice is maybe I'll try 0, 5. Let's try that. So that was no good, the one I chose. Made a mistake here, but that's okay. Let's try 0, 5. So this one was no good. So looking at this one, I have y is greater than -2x plus 1. If I put 5 in place of y and 0 in place of x, I get 5 is greater than 1, and okay, that's true. Now if I look at 8 less than 4x plus 2y, here I'm going to put 0 in place of x, but I'm going to put 5 in place of y, and here 8 is less than 10. Okay, that's true. That means this is the region that I'd like to choose.